Wait, can we hear?
I'm gonna mute myself for a minute. We're gonna wait like a few minutes for people to join.
Yeah, we can wait. We're gonna wait for a little bit. Okay. Perfect. This setup is great.
Keep on waiting. Well, so you guys will be flagging questions, right? There's only
We're
so
gonna
much.
flag, yeah, we'll flag questions, and the questions that we have are like the ones that will set the framework will are just loose, fast and loose, so we don't have to be very strict about them. But I guess we can. Do you want to start in a minute or so, David?
So that's fine with me.
Okay, perfect.
Sí, ya la gente nos está escuchando.
So what's the voice?
Ahí está.
I keep on hearing.
La gente dice, porque tienes el YouTube abierto, se te repite.
No.
Ok, te mandé el link si necesitas, quieres tuitearlo o compartirlo. Hola Nico, Lago y Maya, hola Latem. Bueno.
Pero yo escucho a gente.
¿En dónde?
Sí, se escucha.
Se escucha gente que está,
Yo
que
creo
está
que
hablando.
sí.
Oh, ¿será mi novia que está hablando acá cerca?
That's probably what it is.
Estamos en el coworking space en la sala. Sí. Bueno, sí, démosle un par de minuticos, que ya son las 2:03. Voy a coger un vaso de agua, ya vengo.
Dale.
Wow, 66 personas.
Sí, chévere.
Súper chévere.
Tengo el bombón. Cuando quieran, un minutico más.
Dale, porque tu novia definitivamente sale, se escucha de fondo.
Ok, no, pero yo me callo cuando me esté hablando.
Dale.
Creo que todo el mundo está saludando. I think so. There's a question here. We're gonna try and keep this in English. Is what we're gonna do.
We're gonna keep this in English.
Then we have a few questions and we'll do the Q&A at the end.
Right.
We can say hi to people in the meantime. Hi, Janike.
Hi, everybody. I'm gonna hide the chat.
You guys in Zoom there, if you go, I think, to the top of your browser and go to view, there's a different way, I think, to see who you see. You should be able to see all three of us. Did that? Okay.
Dale, si quieres arranquemos, te presentas.
Okay. So hi everyone. Buenos dias West Coast and buenas tardes East Coast. Thank you so much for joining us today. My name is Alexis, and I don't know who you're seeing, but the other panelist here is David, and of course our guest Elio Morillo, and we're really happy that he is here to talk to us today. David and I are here representing Veoleo and Techqueria, two companies whose mission it is to increase Latinx representation. So Veoleo does that for Latinx kids with books and media, and Techqueria does it with Latinx adults who work in tech. So when we had the idea to invite Elio, it made sense for us to do this together because the topic today is engineering in space. And before we talk with Elio, I wanted to go over some basic housekeeping matters, just so that we're all clear. So first, to submit questions, all you have to do is go to the chat window. On my screen, it's to the right of my screen. So I want you to take a second, see if you can make sure you have it open, make sure that you know how you could submit questions. And you can do
and
this.
there's a new Q&A little button on the bottom too.
Oh, perfect. Okay, that's great. So I'm going to be kind of organizing the questions, so you can start asking now. You don't have to wait until Elio is done. Second, you might be wondering what sort of questions you can ask. And the answer is that you can ask as many as you want. There are no silly questions, and 2-part questions are allowed. And 3, we will do our best to get to all of the questions. We are going to ask some basic questions to begin with, and then we're going to turn it over to the audience. And this is being recorded, and it will be on YouTube. So if you miss anything, no worries, you will be able to find it again. So now we can really begin. We're really excited that you can all tune in and meet Elio and ask him questions, because it's not every day that you can meet somebody who works on the Mars rover. And so everyone at home, you can say, hola, Elio, right? Everyone can just be, we can't wait for you, we can't see you, but hola, Elio. And again,
Hola,
thank you so much. Yes, thank you so much for being here today. So we wanted to start with just, asking you to tell us a little bit about your background.
For sure. I want to make sure I'm here trying to share my screen. I think you guys can see it.
We can see it, and it's on the
Nice.
stream
Okay,
too.
cool.
Yeah, it works.
Yeah, I had some slides I made for another outreach event I had a few weeks ago, so I think this is appropriate. But yeah, I'll go ahead and introduce myself. So thank you everybody for being here. I'm so happy there's so much interest in space. Me llamo Elio Morillo. My story is a very interesting one, as many as yours are. I'm an immigrant. I grew up in several places. I was born in Ecuador in 1993. So my mom decided when I was about 4 years old. So in the 90s, you may have heard about this a little bit. There was just a lot of economic issues. Government was a mess. My mom figured out that it was probably best for us to move to the United States. And fortunately, we had some family already in New York City. So things lined up. We managed to get our green cards, and we moved to New York City. That's where I completed kindergarten and first grade. So it was interesting because I went ahead and learned how to read and write English before I did in Spanish, but I only knew how to speak Spanish very well at the time. And after that, when my mom moved, right, like many of our immigrant parents' stories, my mom had been a teacher for about 20 something years. And, she didn't really know much English. She didn't have to know English in Ecuador, obviously. And after such a long career, she gave that up to, move to New York and then work very tirelessly. During that time, she was working packaging food for one of the airliners, and I don't remember which one, not that it matters, but for one of the airliners. And she was also cleaning some offices. So the thing I always think about that is I can't even imagine doing that right now, where I am an engineer full-time and this is like my specialization, and all of a sudden I have to drop everything and work something that I never envisioned myself doing. But that's the amount of sacrifice my mom was willing to do for me and for our future, which is always what inspires me to keep working as hard as I do. So during that time, my older brother, who's 15 years older than I am, he married a Puerto Rican. So he moved to Puerto Rico. And my mom saw that as kind of an opportunity for her to get back into teaching, and then for me to become fully bilingual by going to Puerto Rico. So from New York City, we moved to Puerto Rico, where I basically spent my childhood. I grew up there. If anyone asks and they don't know any better, when I speak Spanish, my Spanish is full-blown Puerto Rican. It is not Ecuadorian. The cool thing about that was growing up with both foods. I cannot complain. I had both foods growing up the entire time, and I still do. And it's lovely that way. And culturally, I am definitely very much ambiguous. I bounce back and forth. One of the things I've been starting to think of, and if anybody has any good identity lectures or topics to learn more about this, but I've been going along with the idea of ni de aquí, ni de allá, but recently I switched that to soy de aquí y de allá, because really I'm always diving into both all the time with my different friends, with my family. And being part of different tribes teaches you a lot. Both, how to communicate with people, how to be open with ideas. The cultures are all different, so you have to kind of hop around with what's acceptable with one, what's not acceptable with another, and it teaches you and it forms you, which has been awesome. So I grew up in Puerto Rico, and then in around 2006, Puerto Rico started going in this spiral, in this downward spiral of economics, which we can argue so many things about why that happened. But my mom identified, she was familiar with it. It was something that she had gone through in Ecuador just about a decade before. So she said, you know what, before this actually turns completely against us. My mom was a teacher in public schools, which, if you've heard, many public schools to this day keep getting closed. She decided to move back to New York City and bring me along. I was finishing up 8th grade when that happened. So of course it was much tougher than when I was a little kid, because at this point I had my friends.
Right.
I had a certain way of doing things. I was going to school. I had a plan. I kind of had a vision of what high school was going to look like and what to do after that while I was in Puerto Rico. I was fortunate enough to have a scholarship in a private school. So I was being formed up. And of course, with the mom as a teacher, I had no choice than to get good grades, because, that's what teachers want us to do. And, in Puerto Rico and even in New York City, my mom was the breadwinner. We never actually had a car. I didn't have a computer for a long time. Didn't have any internet for probably until middle school, if at all. We had all these, obstacles that my mom, thinking back at it, it's just incredible how she persevered and how she just made it seem like we had everything we needed, which we did. At the end of the day, it was us. We had each other, and we've supported each other along the way. And of course, we've had family and friends that have made our lives, that much easier. In Puerto Rico, I have my Puerto Rican mom, as I call her, and my brothers and sisters over there. Because I just had to develop family wherever I went. And then going to New York City is where I did high school. And I was fortunate enough, the way it works out in New York City, if you guys have heard about this, to get into high school, it's basically going through a college application process. And I had actually missed some of the deadlines because of the timeline I lived through. So I ended up, by complete luck, landing in a school that today is a specialized high school. It wasn't fully vetted at the time, and it was a STEM school. And then I, through working hard with, and I have a group of friends that we all kind of stuck together throughout the entire time we were in our high school. We pushed each other. We kind of set the examples for each other. We had some pretty good guidance counselors as well that guided us through the college application process, something my mom was not familiar with. She did not have to go through that. In Ecuador, not anything like what it is in the United States. All I knew is that I needed to go to college. I knew very early on I wanted to do engineering. I wasn't quite sure what kind of engineering I wanted to pursue, but I was always into hardware, I'm the typical guy that grew up playing with Legos. That stuff I had a lot of hand-me-downs of Legos, actually. And I really like designing stuff, putting things together. So between that and taking a few I took a summer program while I was in high school where I built a robot, which was my real first exposure into coding and building hardware and designing hardware, where I thought, I'm going to be either an electrical engineer or a mechanical engineer. I wasn't sure. And then, of course, in 2008, Iron Man came out. So I was just like, you know what? I need to be anything Iron Man is, Tony Stark all the way, which was actually kind of a cool example to have because it kind of set realistic paths. And from there, I went to University of Michigan, where I completed my undergrad in mechanical engineering. I did several internships and co-ops in different aerospace companies. And then I completed my master's in systems engineering with an emphasis in spacecraft design. And now I'm working at NASA, which is my story in a gist.
That is amazing. That is amazing. So I don't see the screen flip, the microphone flipping. So can people hear me? People hear me? I think so, right? Okay.
I hear you, so I hope
okay,
so.
perfect.
Yeah.
So that is great. I mean, that just really highlights the importance of family, your mom's support, and your community. And I mean, that all sounds amazing. So yeah. I guess a lot of people have a lot of questions about the rover. So we can dive right in. So what does a rover do? Let's start, before we get into the Mars rover for this year, let's talk about what a rover does.
Cool, and that's perfect. I actually have some slides here for that. Let me go ahead and show you, because it is there are some distinctions with this different spacecraft we have.
Okay.
I think can you see my slide with all the different spacecraft outlines?
Yeah, I think everyone can see your screen. Cool.
So it kind of splits off into 3 types of spacecraft that we work with. Number 1, we have orbiters, right? Those are just like satellites that we have on Earth. We will send orbiters that go and observe different planets. And what these orbiters do is that they're inserted into an orbit on a planet, and then they're just navigating around them, taking images, doing all kinds of science. And they'll do that for a period of time as long as we have fuel to control them. Then the second type of spacecraft are the landers, which are these, science hubs. They have a bunch of instruments, but all they do is once they're inserted into the atmosphere of a celestial body, they just land and they don't move. And now, of course, in the rovers are also these scientific labs, but they have wheels and they allow us to navigate whatever local terrain we decide to land. And I'll stick with the topic of Mars here. We've been on Mars since the 70s. We had a lander there. We had several landers that got there. Those were the Viking landers. And then from there, we've been developing the different methods to land different size spacecraft onto the surface of Mars. And we haven't been successful every single time. After all these decades, it's iteration upon iteration, learning from our mistakes. If we fail, that doesn't stop us from trying again. The idea is we learn from our mistakes and we build a better spacecraft and we try and land it the next time. And that has happened. And then based on what is successful, then we'll build on top of that. Because first of all, it's really expensive to get to Mars. So we can't just throw money all the time to try again. We have to be very methodical. We have to be very careful. What gets selected, because there's so many scientists and so many instruments that people want to send to Mars, but there's only so much space and so much we can actually send to space with our rockets that we have to be very careful and very considerate with how we pick designs, how we pick instruments, what missions get picked in the first place. There's a whole process for that. And people spend their careers, people will spend their careers designing spacecraft that maybe, a decade after they've graduated from their university, or maybe 2 decades later even, that's when they actually get to build the hardware and send it to Mars. There are people that dedicate their lives to building missions for Mars. And that stuff is very admirable. And I'm very fortunate to work with a lot of these folks that have been doing this for so long and to learn from them. Because I'm a baby in all of this. I just started a new career. And space is really difficult. Space is hard.
Well, so that's good to keep in mind.
Yeah.
I think that's great perspective, right? Because I think we all are always learning, and what we know compared to what we don't know is crazy. So, how long does it take to get to Mars, or how long will it take the rover to get to Mars?
To give you an idea, this particular rover and the way the orbits work, we're going to launch this upcoming July, if all goes well.
Okay.
And we shall be getting to Mars around February timeframe. So it takes that long to get from Earth to Mars. And it's something to think about and appreciate, because there's a reason we haven't sent astronauts quite yet, right? Like imagine being in a tiny little capsule for that long with very limited resources, with limited amount of space. You know, robots fortunately are more manageable and are easier to work with than human beings, but we're getting there. All this stuff is teaching us how to navigate through space and one day send astronauts to the red planet. But it takes, you know, between 6-7 months.
Wow. So
to get to Mars. That's about how far it is, but other planets may take years even.
Oh, wow. Oh, okay. Well, I have 2 questions then. 1, would you like to go to Mars? And 2, do you have a favorite fact about Mars?
To have a favorite what?
A favorite fact.
A favorite fact?
Yeah.
That's funny. I don't know if I've ever thought of that, but will I like to go to Mars?
Yeah.
You know, no, not really. I think one of the cool things about working in space and working with space is that you really start, or it opens your eyes to a different type of appreciation for Earth.
Okay.
When we look up and when we look up at the universe and at all the celestial bodies that are out there, and first of all, you start recognizing how special we are as human beings to be able to survive on this one little blue dot, right?
Right.
It's very difficult to imagine leaving this planet and going and forming a life elsewhere, because this planet and the way we have evolved is very specialized and very specific to the atmosphere and to the conditions found here on Earth. Right. Something that many of us talk about all the time is like the first people that end up going to Mars, or you know, I mean, Mars is realistic. They're going to be some of the bravest people to ever have lived on this planet, because the psychology one needs to have to understand that you're going to get in a tiny little capsule with limited resources to a planet that is pretty much barren. There are resources we will be able to use, and that is something that we're working on. And then traveling through space, landing on another planet, and then, you know, taking those first steps. It's going to be incredible. It's crazy to even imagine that. I do like The Martian. That movie does a good job in showing what that's like, and the dangers of space travel. I don't think I am amongst those people. I will continue working on my robots that will do the work for me. And I will gladly support those human missions. But I mean, who knows? That's what I'm saying now. Ask me 10 years from now. Right. Like, I don't know what it'll be.
Well, we'll definitely catch up with you then. So let's talk about this 2020 Mars rover specifically.
Yeah.
What will she do? You already mentioned when she launches. You said July, right?
July. So if anybody's in Florida, and you know, if all goes well and people can travel to Cape Canaveral by then, you know, it'll be visible. The launch will be, it'll happen. It's exciting. It's you know, it's exciting times for this.
Will it be televised?
Of course, yeah. This is going to be,
great.
you know, it's a yeah.
So
most rocket launches are. You'll find them on different streams. You know, there's several services online and apps that tell you when launches happen, and many of them are
cool.
Just in general, they could be commercial or some of the scientific payload stuff from the different agencies, right? Because NASA launches from Cape Canaveral, then you have the Japanese agency, you have the European Space Agency, the Chinese Space Agency. All of these have launches all the time, and many of them are televised, and they're just
okay. Cool. That's cool. So I had actually asked Elio about this earlier, and he sent me some really useful links. So I will circulate those links after we're done. And some of them are live feeds. So I think that'll be really interesting to look into. And that's something that you can check every once in a while and see what's changed. So what will this Mars rover do? Does she have a specific mission?
Yeah, so the Perseverance rover, and there's more details of this in the links that we're going to share. The Perseverance rover has 4 main scientific objectives, and number 1 is to continue studying the geology and the atmosphere of Mars, to give us even deeper understanding than what we already have of the red planet.
Okay.
Number two, which is a big one, is try and figure out. I'm going to pull this up because these are actually very useful. I was looking at them earlier. Let me start a new window here because I want to make sure. Can you guys see what I'm looking at?
We can see a Google page, right?
Yeah. So March 2020. The second objective. Here we go. This is all the public stuff. So this is really neat. All right. Let me go to the mission overview.
Oh, it launches in 113 days.
Yeah, it's counting down, and it's real, and it's kind of terrifying to think about, but we're working on it.
Fun. So I was going to ask you. I was going to ask you just before you continue what her name is, because it's a beautiful name.
I think so.
And I wanted to ask you if you call her a she or an it.
We call.
Or do you have a nicknames? Does she have nicknames?
We lovingly have started calling her Percy, just because
Percy?
it's easier to say. But yeah, typically spaceships use female pronouns.
Oh,
I think
that's cool. That's a cool fact.
It comes from, I mean, you know, sea ships. That's how typically they've been referred to. And I guess it's just a practice we keep with spaceships. But yeah, Percy's going to be doing focusing on these four things here. Like I started talking about is continued characterization of Mars, determining whether life ever arose on Mars. And that one's interesting because it splits into several ideas. And there's going to be some instruments that are going to allow us to take a look at rocks a little bit closer. Something that, to think about is that the way we look for life on other planets, for the most part, has to do with the understanding we have of how we find life on Earth. So if you guys look into how the landing site was selected, the landing site is it's called Jezero Crater. It's very much akin to, I forgot the Mississippi Delta and the formations that we can currently see there. And we know that, some of the formations there have interacted with water over millions and millions of years and different temperatures. So we think that, if we found life in places like this here on Earth, let's look for life or biosignatures, really. That's what we're going to be doing in places like Jezero Crater. And then part of the mission is that, once we find some of these very interesting rocks that could potentially hold, something that looks like organic material and we don't quite understand it, the Mars 2020 mission is the first step in a sample recovery mission, a sample return mission. So what the rover is going to do is that scientists and the scientific community are going to deliberate what rock is interesting enough that we're going to actually cache it and put it in a basically a tiny little metallic container so that a future mission can go pick it up and bring it back to Earth. And that's probably going to happen within the next 10 years after we've done our part with Mars 2020 with Perseverance. So that's exciting, right? Because there's only so many instruments you can put on the rover. So if you want to do some more in-depth science and try again, then we're going to have to bring that stuff back to Earth where we have proper scientific equipment. The scientists are all going to be here, and they'll be able to have better conclusions and better insight into what we're bringing back. Along with that, something that's also very exciting in all of this is that we're going to continue building on the knowledge to one day bring humans. One of the exciting instruments we're sending on there is actually going to try and test oxygen production from the Martian atmosphere. So we know that the Martian atmosphere is mostly carbon dioxide. And of course, if humans go there eventually, which we will, how can we convert that atmosphere into something that's usable to us? So that is something that we will be testing with this mission. And you can test it in labs here. We can, prove that this instrument in a chamber that's only filled with carbon dioxide, that it'll
Mhm.
work. But now I think the difficult thing is, how do you do that with a 6-7 minute lag, communicating from one planet to the other, how much is being produced, how much we want to produce, and then of course all of the other different things we have to control and be thoughtful about. You know, we won't, this instrument can't be on at all times because we have to control temperature, we have to control how much power is used. And these are the things we want to learn through operating this instrument. Because eventually astronauts that go to Mars will have to, they will need something similar to be able to work and survive on Mars.
That's, I mean, it's all so fascinating, especially how you have to, how you can, like the testing part, I think is really, really interesting. Because, for example, how, like there's hardware and software, right, on Perseverance.
That's
So how do you test the hardware, right? Like how do you know that Perseverance can roll on Mars' surface? Like how do you test for that here on Earth?
That's right. So funny you ask, because that's my job.
Oh, that's your job?
That's my job. So I'm part of the, what we call the System Testbed team. So we build several versions of the hardware. We build the rover that's going to Mars,
Mhm.
and then we'll build the sister rover that stays with us. So if you guys have watched The Martian, I think that's the pretty cool example to talk about. Is that in The Martian, they have that room, that lab, where they have all the rovers, like the Earth versions of the rovers, and that's how they debug problems on Mars. Well, I work for that lab in the real world. It looks a bit different than what they show in the movie, but they capture the idea pretty well, where we have the Earth versions of the rovers. And we do exactly what you mentioned, where, you know, there's so many teams that are working on developing software, so many teams working on developing the hardware, and then my team basically takes all of the subsystems, integrates them as a system, and we try and have fun with it, basically. We test it for the nominal things it was designed for. So, you know, the rover is supposed to behave in a certain way,
Mhm.
but then we'll also try to push it to its limits to see, you know, how can we break it and how can we fix it? Because once this thing is on Mars, we don't have Martian mechanics that can go and fix
right.
you know, the rover, right? So we have to be able to, you know, foresee what problems we may run into, hopefully fix them before we've launched. And then while we're operating on Mars, if we ever run into any issue, we try and replicate them so that we can debug them and, you know, upload things through software basically to find workarounds and solutions to whatever issues we may run into.
Okay. So somebody was asking what The Martian is, and The Martian is it's a great movie. And oh, sorry. Yes, you are totally right. It is
based on
I can't believe I forgot that. I read the book too. So it's a great book. So it's a great book, and it was made a movie also, and it stars, why am I blanking on his name?
Matt Damon, right?
Matt Damon. It stars Matt Damon. So it's definitely a great movie, but it's about an astronaut that gets stuck on Mars and about how he has to get off. So it's definitely a fun watch if your parents let you watch it. So, all right. So how did Perseverance get her name?
That was a fun, you know, a fun process. So the Perseverance name came from a nationwide competition from students, you know, from kindergarten through 12th grade. And they all submitted essays with their name ideas, and they had to all back them up. And then volunteers read through thousands of essays and kind of, you know, boiled it down to a few options. And then we had a group of JPLers that ended up picking the name, and Perseverance ended up winning. And I think, you know, and what we're living through right now, I had my personal favorite. I had another favorite for the name, but I think the name is very appropriate based on what's, you know, what's going on outside of our houses right now. Despite it all, we're gonna get through this. It does definitely, you know, it captures the spirit of the country, especially right now. and we're going through some tough times, but despite it all, we will we will persevere. We will be okay. And I really appreciate the name, because if there's something to look forward to this summer, it's the launch of Perseverance to Mars.
That's true. Can you share the name that you originally wanted, or do you want to keep it secret for a future,
no, it's fine.
For a future rover?
It's fine. It's Perseverance Rover, and I've learned to appreciate it for sure.
Okay. So you can't share the one that you originally wanted?
Nah, it's fine.
Okay. So before we turn it over to everyone that's online, I guess just two more questions. One is, does speaking Spanish ever come in handy? How do you feel that being Latino has affected the way you approach your work? I know before you mentioned that because you felt Ecuadorian and Puerto Rican and American, that you were able to kind of navigate different cultures. And then if you have any advice for kids that are interested in what you do. And then after those two questions, we will, we'll start going through the Q&A questions.
Yeah, I mean, I definitely speak Spanish every day. I speak Spanish with my family, with my friends. If you guys think I don't blast Bad Bunny in my lab, you're wrong.
Bad Bunny, do you think the rover will blast Bad Bunny on Mars?
There's a few gems. Sometimes maybe we hide it here and there. I don't know. Maybe. I hope.
That would be great.
If I can get my teammates to do that for me, that'd be great. That'd be amazing. Actually, it's funny. One of my teammates and I were saying the unofficial soundtrack of the testbed team right now is one of the songs from Bad Bunny. Yeah, I definitely speak Spanish. It's awesome. Also, particularly here in SoCal and where JPL is located. At work, I don't use it when we're speaking, technical stuff. First of all, my technical Spanish is very different. It's very basic. I've been learning the technical Spanish because I've had to present to students before that only speak Spanish. So that was a hurdle, but it's been awesome to kind of pick up the terminology in Spanish. But at work, really, I think something that's cool is with a lot of the staff that supports, the cafeterias, the custodial staff. I speak in Spanish to them and I befriend them. And, with some of them, I'll actually, invite them and their families for a tour, because I'm like, you guys have to see this.
Oh, that's great.
You guys have to, this is all reachable. It's within your means. And you guys are here supporting us all the time with everything you do for us. And, show them appreciation, especially at times like now where there's, well, right now they're not in the lab, but they're always there for us, providing us, nurturing us, and I think that's really important. Something here in LA, of course, that's awesome is in the particular area I live in, I can still go to the panaderia and speak to them in Spanish. I love that. It makes me feel at home, which is really cool. And I definitely try and I mean, I'm never going to forget my identity at this point. And that's something that I like to talk about, is that many times, and as the second question, what advice about identity? I think many times people try and throw all this terminology at the individuals, at us. And I think it's the individual's, responsibility, and we should all feel empowered that we pick whatever identity fits us. We should not let people pick what identity fits us. So when people tell me, oh, you're not Ecuadorian enough, oh, you're not Puerto Rican enough, oh, you're not American enough, it kind of flies through my head because I have a good grounding of my self-understanding. But it is a battle I fight often, because people do tend to be pretty tribal. And then I remind them that I am a part of all the tribes. So it's kind of, it's a cool discussion to have when I have the opportunity to have it. So that's kind of the advice I give people is, try and best to understand the identity that fits you best. And that could be multiple things. You are all your own people. And that's kind of part of the freedoms we enjoy and take advantage.
That's so great. So let's move over to the Q&A, because we have a bunch of different questions to go through. Sure. And there's a lot, so I will try.
Okay.
I will try to see. A question from Emilia, age 7. How do you know when the rover will be ready to launch?
That's a great
when
question.
do you know? Yeah, when do you know she's ready to go?
That's a great question. So there are specific teams that review the testing campaign, the results, the data, and then of course ultimately it's up to the NASA administrator to say, hey, all of these things passed, all of these reviews, all of these checkpoints really that we have, we're good to go. Many, in the past, this is just as an example, in the past, I guess, take a step back here. The launch windows to Mars are very brief. Like if we don't launch within the launch window we have selected, it has to do with just with the distance between the planets and the current rockets that we use. If we don't launch within the July, August timeframe we have, then we have to wait 26 months to enter that launch window again. So it has happened in the past. It happened with InSight. Right. It actually happened with MSL, where for whatever reason, we decided, hey, the hardware is not ready. There's risk we do not want to take. We have to delay it for 26 months, and that happens.
Wow.
And it's tough because budgets have to be played with. It adds to the budget, and of course, it's a lot of money. So it's all taxpayer based as well. This is all your taxpayer money at hardware. Okay. So pay your taxes, and this is probably the best return of investment you get for your taxes, is what I like to tell people.
That's amazing.
So there are many checks that have to happen before we say, what, it's good to go.
It's good to go. Okay. A mechanical question: why does the rover have so many wheels?
Oh, that's a good question. Basically, we need a mobility system that allows us to navigate through specific terrain. So it ends up being a whole process to select, what works best. And, 4 wheels that you see on cars versus 6 wheels that you see on the rover, each have their own function and purpose. So when the original designers were selecting what was best, they had to figure out, through case studies and through trade studies, what's going to work best to, go over rocks that are, say 7 inches tall. Can we jump over that with 4 wheels? Can we jump over that with 3 wheels? Can we navigate with all the weight that we have? And those are the studies that are taking place. And then the experts, of course, then go off and design all these different mobility systems and test them, and then decide, what, this is the one we want to use for all these rocks and for this particular terrain. Right. And that's the process. So for MSL and for Mars 2020, well, the 6-wheel rover just meets our design constraints very well.
Okay, cool. So somebody else asked, Marcia asked, do you make blueprints for the rover, and how do you make them? And then somebody else asked, I lost the question, but I read it. It said, what software or what coding language does the rover run on?
Oh, that's a good question. So blueprints we make drawings. The mechanical engineers and even the electrical engineers, everything has a drawing, and it's all documented so that we can test and understand what we're building very well and how to build it. There are folks that specialize in this stuff, and it's really important to have all these very special skills. And a lot of people specialize in this stuff, and it's a lot of fun. So I before my current job, I was actually a mechanical designer. So there's a very specific set of tools you use to model all the parts, and then you make the respective drawings so that someone can take that drawing and build parts accordingly. And then when you receive the part, then you'll be able to match it to whatever drawing you had made originally and say, hey, this part right here doesn't quite match my drawing. Let's rework it. And, and that's kind of the process that goes with that. In terms of the software, so several languages are used across different tools, different the different computers we have on board. I personally interact with Python a lot, so I always tell people to use Python. Python is great for data analysis, and it's very easy to learn and pick up. Like I told you guys, I'm a trained mechanical engineer, and all of a sudden I am coding almost every day now, which is interesting.
Oh, okay.
But yeah, many languages interface with our system. You can't go wrong in picking one to learn. And there's so many resources, especially right now with the whole stay-at-home campaign. There's a lot of free classes popping up.
Yes,
and there's a lot of projects for kids. It blows my mind, the stuff that's out there now that I wish I had when I was a kid. So parents, if you have access to any kind of robotics teams, or even online on Amazon, you can pick up something relatively cheap and your kids can pick up coding early on. And it's a skill that's, it's just in higher demand as time passes. So you can't go wrong with that.
Perfect. Manny is asking, how long does it take to build the rocket that the rover is sent in to go to Mars?
That's a good question. I'm not entirely sure, but that rocket, it's owned by the United Launch Alliance. So you can probably find that online, but it's a pretty big rocket. It has been tested. It has been used, the design has been used several times and has not failed, which is really important for us. So I recommend probably going online and doing a deep search into the different kinds of rockets and the one we're particularly going to be using. Because it is fascinating. I don't interface with the rocket, but there's big teams that definitely do.
Okay. Bridger wants to ask you, how many miles per hour will the Mars rover run?
On the surface? Oh, yeah. On the surface, it's actually pretty slow. Something to be mindful of, and it's not even in the miles per hour. It's in the centimeters a second.
Centimeters a second? You guys,
yes.
this is all a call for you to also learn about the metric system.
Yes, that too, right?
Yeah.
The thing we have to be mindful of, right? So there's quite a bit of a lag with how we command the rover to move. So the analogy I give people is, imagine, many of us have used remote control cars, remote control drones even, right? When you throttle that, that thumbstick, the response you get is immediate. Well, imagine throttling that thumbstick and then having to wait 7-8 minutes for a response. Wow. That's about how long it takes for a signal to get from here to Mars. And similarly, that's how long it takes for the signal to get from Mars back to Earth. So we want to be very careful with how the rover moves, because it'll be doing it on its own. And it has its own methods of understanding its surroundings and how to do a little bit of autonomous navigation. But we still want to be careful, because obviously once this thing is on Mars, we can't quite send somebody to go fix the wheel, right? So we have to be conscious of how we drive it.
Somebody asked, I'm reading the questions, but then I'm skimming them, so I can't necessarily find them. But somebody asked that a past rover had tears in the wheels. And do you think that will happen again?
So the wheels have been designed to be more robust this time around, but it is natural, right? Metal just degrades over time. And Mars has some pointy rocks. So if you do look at the pictures from MSL and the previous rovers as well, both Spirit and Opportunity, you start seeing this degradation over time, just because the rovers are just roving. They're going around through the surface of Mars, and then eventually that metal starts caving. It's a natural behavior of metal, but of course our designs are optimized as best as possible to fit our weight constraints and also our usability in our lifetime of the rover. So something we are conscious of, and that is a good observation, and that's something we design around.
Well, so somebody else asked, once you have made like an increasingly advanced rover, can you call the old ones home? Or what would you do with the really old ones?
They're still on Mars.
Okay.
Some of them are non-functional. There's really good stories about them, and I encourage people to look into the Opportunity rover in particular, which was designed to only work for 90 Martian days, and it roved around for 14 years.
Oh, so,
wow. Just to show you the level of engineering we do and how we design things. but who knows? Maybe they'll end up being museums on the surface of Mars one day. But they definitely stay on Mars.
Yeah.
We don't bring them back.
Okay. Luca wants to know, how much electricity do you need to run the rover? And what have you learned at work that you didn't learn in school?
Everything. No, I think I'll address the second question. The first question is a bit too technical. I won't get too much into the details, but I'll just say that the power levels of the rover are surprisingly, it may be lower than what you expect. So we design our electronics to function at, very cold temperatures and at very low power constraints. And that way our batteries just last a long time too. But it's fascinating. And I'll say that with school, the way to best approach it is we end up learning, those first principles, the fundamentals, the Newton's laws, the math. But when you work with the real hardware, there's so many variables to always think about that much of what we do, we learn by experience. And of course, when we're designing and when we're iterating on designs, you have the experts, subject matter experts that have been doing this for a long time, people that specialize in the many topics that are required for space. And things get done, things get built. Sometimes not as best as they could have been, but that's something that we learn over the years as we look back at our designs and iterate on them for the following missions. But definitely, I will say, pay attention in school. That was very important to get to where I am today. Try to do as best as possible. Always do your best in anything you do. Try as best as you can to pursue a degree in engineering. I will be biased. That is the future. Our future is very technical, and most problems have technical solutions, but that doesn't mean you should not be paying attention to your social studies class, because something that's very important and in all of this is that, especially in studying history, we start painting bigger picture for ourselves and understanding our place in whatever it is we're involved in. So be well-rounded, but pursue your interests, is what I'll say to that.
That's great. And then, I mean, that makes sense, right? That you need to know, you need both, right? Like you need the technical expertise, you need the historical, you need the humanities, you need to see how everything comes together. Athena wants to know, what does NASA do, or what can NASA do if a rocket goes off course? Like, is it possible that you would lose Perseverance?
It's something we don't talk about. Let's not talk about that. But I will say that there are mechanisms in place, and this has happened in rocket launches in the past, where if for whatever reason the rocket diverts, the Air Force actually has methods of exploding the rocket if necessary, and minimize the damage. And I mean, I welcome people to look up on YouTube rocket launch failures. They're incredible. But we learn from them every time to take the precautions necessary for that to not happen again. Obviously, it'd be very expensive, and that's not something we aim or desire. And even further, I think it's really important to think about that stuff when we talk about human launches. There are, the disasters that happen with the space shuttle. Those have their own case studies that I encourage people to go read about. Many times they are human mistakes, and they cost lives. So we have to be very conscious of how we approach engineering and what kind of constraints we put on ourselves.
This is a quick and easy question. If you ever leave NASA, would your Instagram handle be the same? Because I guess people want to be able to follow you.
TBD. I don't know. That's funny. I hadn't thought about that. But yeah, at the Space Mechanic. I was surprised that was available. I'm
surprised it was available too.
Yeah. So follow me on Instagram.
So some people are a lot of people are curious about how you found your job, because you said that before joining JPL, you said you were an engineer where?
So I worked at several other companies. In undergrad as internships. I got the experience, something I encourage people to do while they're in school. I worked at several companies, and then I had the opportunity, something for people to look into as well, something that has helped me tremendously, both in my soft skills and my personal relationships, the Society of Hispanic Professional Engineers.
Okay.
There are student chapters for that as well at the high school level, and there's a lot of outreach events for middle school and lower school even. I didn't have exposure to that in high school, but I became extremely involved while I was in undergrad and grad school a bit. And now as a professional, I'm returning into the ship scene. It's pronounced ship. You may hear it from other people. The Society of Hispanic Professional Engineers, ship is the way to go. And I'm gonna get probably a lot of crap for that because the people say ship in other places, but it is what it is. Yeah, I had an opportunity there. I have a lot of mentors through that organization. And there's events every year. There are the national conferences. There are the regional conferences that happen at the local levels throughout the country. I encourage you guys to visit the website, and professionals sign up, students sign up as well as members to learn more about engineering. And I think it was a good sense of family while I was in undergrad in particular, where I went to the University of Michigan, which is not known to have the most Hispanic numbers in the country, right? So it was cool to have that community and that family at the end of the day on my campus. And through SHIP, I went to one of the national conferences, and that's where I met my current boss, who's also Latino. So it was pretty fantastic to get connected with him there. My skill set and my preparation lined up with the team and my interests. So it was one of those, we get along pretty well. Eric Aguilar is his name. If you guys, I don't know if Eric's on there, or I don't know if he's around.
I don't know.
He's probably working really hard, and I'm gonna get
not online.
But yeah, I met him there, and things worked out. I started as an intern at JPL and became full time after I completed.
Oh, great! That's amazing. So was that? I mean, I'm assuming that this was your. I mean, it's to me, this would be my dream job if I were an engineer. So were you? I mean, was that just like a dream come true when this opportunity came across?
Yeah, it was something I envisioned myself. Like I didn't obviously know the terminology for it when I was growing up. But if you asked me when I was a kid where I wanted to be or what I wanted to do, it would have probably been this. Right. Which is, it's kind of been an incredible kind of revelation to myself that's where I'm at. It's something I think about and that I'm very grateful for, all the people that have helped me get here. And who knows what's next? That's the crazy thing too. It's like, where do I go after this? Is something I'm kind of working on answering myself, because it is a dream job and it's a lot of fun, and I have great teammates too. So I'm kind of lucky as to where I am.
Yeah, you answered somebody else's question who wanted to know what was next for your career.
TBD.
So this is a fun question, and you can say no. Somebody asked, what is your favorite space conspiracy, if you have one? Maybe you don't have one.
There's so many. There's so many. Though, I mean, what I'll say is that I personally believe that we're not alone in this massive universe. It doesn't make mathematical sense. Okay. So that's as much as I'll say to that. But there's so many fun conspiracy theories. So pick and choose from whichever. I'm not too crazy about any of them, really.
Great. All right. So we have actually had over 75 or 80 questions submitted. We still have 55 open, but it is 3 p.m. So I'm going to choose 2 more, and that's it.
Okay. Yeah, so I can get back to work.
Yeah, exactly. You have to get back to perseverance. Let's see. Oh, this is a good one, but I don't know who submitted it. What would you consider the most impactful pivots or light bulb moments that have led you to be where you are today?
That's man, light bulb moments. So I think a story I like to talk about a little bit, because it was kind of a light bulb moment. going to the University of Michigan, there's a pretty cool story with that.
Okay.
So I got accepted into several schools when I was in high school, and then I had pretty much set my eyes to Carnegie Mellon.
Okay.
They had given me a program to go and visit for a weekend. It was like a Latinx and weekend with, it was a diversity weekend. That's what it was. And we got to go there and spend some time on campus and meet people. It was great. I hadn't had the opportunity provided like that to any of the other schools.
Okay.
So I didn't have the means to go travel to other schools. So I was just like, you know what? I visited the campus. It's awesome. The programs are awesome. That's where I was gonna go. And then once I had actually accepted, I got a call from, his name is Mr. Cook, Dave Cook.
Okay.
He's awesome, from the University of Michigan. And he calls me up and tells me, hey, you haven't accepted this program that we've accepted you to. Why haven't you? And it was a program to go spend 6 weeks at Michigan for the summer before freshman year.
That's amazing.
And I was just like, I've not heard about this program. And there were some incentives to it too.
Mm-hmm.
And I was like, I have not heard. And it turned out that they had the wrong address. So I hadn't been in the mail. And then I told him, hey, I haven't visited the university. I don't really have a clear way to accept. And then he tells me, hey, what are you doing this weekend?
Okay.
And he personally, you know, I mean, they flew me out. He personally, like, one of the students of the previous cohorts picked me up. Then he personally showed me around campus. And it was that level of warmth and, you know, acceptance into the community at Michigan that kind of convinced me that that was going to be the right fit. And it absolutely was. The University of Michigan was amazing. I met so many people. The classes I took were awesome. The professors there are incredible. I don't have too many things to complain about. I mean, I was exposed to football there for the first time. And that was one of those moments that kind of pivoted where things were going to go. So yeah, that was one of the best examples I have for one of those light bulb moments that said, you know what, I guess I'm a Wolverine. And I can't tell, I'm pretty proud.
Okay, and then last question. This is from Nico. Nico wants to know whether the robot has feelings. And I think that this is a great question to finish on because her name is Perseverance, she's a she, and we're in the middle of artificial intelligence. So do you think that rovers like Perseverance will one day have feelings?
You know, probably. Who knows what the future holds with artificial intelligence. I will say that you know, a lot of the way the rover works is that it has many sensors that give us feedback all the time. Like, hey, this part of the rover is too hot, so how about you don't use that robotic arm to do anything? Or hey, I've used too much strength to push against this rock. Slow it down a little bit. Take it easy on me. Or there are constraints on, you know, how much the rover can do, and the rover, if we try to do too much with it, will give us feedback that, hey, you know, stop that. And so in a way, I guess it does kind of have its own set of feelings.
That's great.
Yeah, it's all in the programming, so it is an interesting thing to think about it that way.
That is, yeah, I know, that's fantastic. Because like one day she'll ask you for a coffee break.
No, maybe, yeah.
She should be like, this is too much, I need a nap. That's so great. Well, Elio, thank you so much. This has been amazing. And to all of our participants, I'm sorry that there are still 50 questions or more than 50 questions that we couldn't get to. But this was so great. Thank you so much. And
thank you guys for being here. Thank you guys for inviting me.
No, thank you so much for your time. This is great. The video will be on the Techqueria YouTube so that you can share it with your friends later if they couldn't come. And yeah, thank you so much for also talking about CHIP. We love CHIP. Is like a sister organization or brother organization of Techqueria. We love what they do, and it's great to like see more, you know, people like you coming out and becoming like role models for all of us that you know, want to change our careers and our families and our societies. Yeah.
No, it's great. It's absolutely great. And we're so happy that we could make this happen while everyone is in quarantine. You know, it's great to learn new things. You guys, if there's any other questions that you have you can try to follow up, or you can look it up. I'm sure that there's a bunch of questions going on in your head that we didn't get to answer, but that you should.
On the NASA
yeah.
website. And of course, YouTube. Just watch out for those conspiracy stuff. But aside from that, there's some really good resources out there to learn all about Mars, to learn about the missions, what has come out of the missions, right? Because we do this to ask big questions and try to get answers to them. And yeah, feel free to reach out on social media, I guess. I'll take breaks here and there and check if people have any questions.
Perfect. All right. Well, thank you so much, you guys, everyone. Thank you. And we will see you again soon.
Thank you so much.
Bye.
Oh,
Alexis.
Bye.
Wait, Alexa,
Yeah.
I mean,
Yes.
Elio, do you have any cool astronomical objects that we could take a selfie, like a group selfie?
I'm behind a poster that says Base Lunar.
I have
So
this
that's
rock.
my
That's
my contribution.
That I think was from some
Oh, it's cute. Look at the rover.
little rover.
That is great.
Uno, dos, tres. Cool.
Thank you so much. That was a great idea.
Yeah. Have a wonderful day.
Bye.
Bye.
Bye, everyone. Bye.